Thanks again for joining this online meetup, which we started just a few weeks back. In this particular meetup, we are going to cover two things. One is we look at overview of Kubernetes Debugging Monitoring. We look at most of the default tools which comes with Kubernetes, which I would do. This would be around for 25 minutes, and then we would have Prasad from InfraCloud who would talk about BotKube. He's the maintainer of the BotKube project, using which we can do real-time Kubernetes monitoring, alerting, and debugging. So that's what the agenda for today. So with that, let's get going. Yeah, so quick intro about myself. My name is Neependra, and I'm founder at Cloud. We have been providing consulting and training in the area of containers Kubernetes for around 4 years now. I have also authored the official CNCF's Kubernetes course, which is an intro one, which has been taken by more than 100K participants around the world. I'm also a CNCF ambassador and been in the industry for around 15 years now. Okay, so let's get going into the topic now. So when you talk about debugging, so there are some default commands with the kubectl which we can use to do some basic level of debugging. So that's the topic of today's talk anyway. So whenever you deploy any pod, a service, nodes, or whatever in the cluster, you can always use a describe command. So for example, here, so this is a cluster I am running. This cluster is currently just a single node cluster. Let me show you that. Yeah, and I'm running few pods there. So, and of course, there will be some services and so on. The basic thing you can do about anything to start debugging is to describe the respective object. So for example, if I want to describe any object here, I would say describe as a command, then the object type. So if object type is being pod, so I'll say the pod and the pod name, right? So with this command, I'm going to get some information about the respective object here. In this case, the object being pod. So I can get the pod names, the namespace is running on, annotations which we have defined, the IP address of the pod, and then we get what are the containers in that pod. So if your pod has multiple containers, you would get the information about that in this section here. Then you would get other information like, for example, the state, start count, and so on. And then you would eventually have the call as events. Because this pod created some time ago, we don't see any events here. But if you create a new pod, you would see that events would come in this case, right? So I'll show you that events also. So let me try to get that events thing as well. So show you. So actually, I have copied one file here. So let me just. It's a very simple deployment file which I have. I'll just copy it here. It's already there. Good. So if I just go ahead and apply this. And then if I look at the pods now, pod whatever we created here, then if you describe a pod here, in this case, so you can see that I'm getting some events here. This is the very basic level of debugging you can do. So whenever something is not working for your pod, you can do a describe and find out what's happening here. For example, there's one more pod we have in our environment here, which is failing like for a lot of times. 41 times it has been failed, right? Reset for 41 times. So let's try to describe this pod and see what we can get. So let's try to describe the pod here. And you would get some information about here. Yeah. So it's saying that liveness probe has failed. And basically we're trying to run a Nginx pod there, but we're doing a health check on port 81. So it's supposed to fail. So that's what's happening here. So this particular command can be very useful while starting on debugging in any way, right? Similarly, you can debug a service, node, and so on. So for example, if I want to debug a service here, so So I could do a same thing, describe service and a service name. Now, one good thing about, one thing you can definitely figure out with the service that do you have any endpoints or not? Endpoints are nothing but the pods which are being connected by this service. So if I am running X amount of pod and they are supposed to bound to a service, but for some reason I don't see any endpoints here, which means my service is not able to reach to the backend pods. So the reasons can be your labels and selectors are not matching. For example, in this case, we have given these 4 labels here for my or 5, whatever the number of labels I have given for this particular pod. Look at the selector here. The selector, we are saying that I should be able to select these selectors here. So basically every pod have some labels and service connect to those particular pods via these selectors. So they have to match, not exactly, but look at this is a partial match here, but that's fine because our service can select a pod which have those labels and perfectly fine. So when you debug a service, make sure that you can see those endpoints. Otherwise, you need to figure out either the pods are running or not, or I have the right label selectors matching in my configurations or not. So when you define a service, you define a selector, and when you define an object like pod or deployment, you select a label there. You put a label there, and then these selectors on the service has to match with the labels of the pods there, and they have to match. Otherwise, it's not going to work. The events here. So let's look at the events here. So I showed you already the events as a part of the describe of the pod command here, but I could do kubectl get events command as well. This event command gives me the events happening in that particular namespace. So currently I'm in the default namespace. So when I run any of my pod creation, pod deletion, or like failure, whatever it is, right? You can see that I can get all those events on my screen here. So whenever you're seeing any problem in your namespace, your pod is not running up, they're restarting and so on, you should always run this command, get events for that specific namespace. And if you can do all namespaces, then you will get the events for all of the namespaces. This is again a secondary command which I always use to debug why my pod is not restarting or why this is happening and whatever it is, right? So anything about pod services, whatever it is, you should run these 2 commands in a very early debug phase. Logs, describe, and logs we talked about, describe and the events command, right? So you can get the name events per namespace or all the namespaces here. Then there's a command called exec. So with that exec command, you can exec into any one of your running container and then see what's happening inside that. So I think everybody would know about this thing, but let me just show you one time here. So whatever number of pods I'm running, I can say I want to exec to one of my pods container here. So if I pick up, for example, get pods I already seen, exec, and it's IT for interactive and the TTY terminal there. And I would like to exec to one of my pod here. So I kind of go into a pod. So that's what I did wrong here. Okay, anyway, I'm inside the pod now. It's saying that you should do this hyphen and the command there, rather than specifying just the command directly. So once I'm in the pod, I can command not found, but that's fine. But I'm trying to say that I can log into already running container or the pod there, and then run whatever command I would like to run there. So the PS command is not there, but that's fine. So this is the case when I had only one container in my pod. But if I have 2 containers in my pod, then how would I exec? So here I have a container, I have a pod with 2 containers here. So I can do a describe first to find out what are my containers names in that pod. Right, so this will give me the container names. Like here in this particular pod, I have 2 containers. One container is called config map reload, and other is the Prometheus server. So then I can choose which container I want to exec into. So let's do that. So kubectl exec -IP. And then I can say -c in the container name which I want to exec into, and then shell, whatever command. So I'm now inside the second container, which is Prometheus-server, and I can run those commands inside that. So I can debug a live pod which I'm running. That's one. Similarly, in the recent release of Kubernetes 1.18, we got a new feature called debug. So with that, we can attach an ephemeral container, or so suppose you are running any app which doesn't have a lot of debugging tools and so on. So what you want to do is you want to kind of exec into it, but you want to exec with your own custom commands. Like for example, you want to do a TCP dump in a container, right? And TCP dump is not there in that previous basic application what you have deployed earlier, right? So what you can do is you can kind of have another image which can have a TCP dump installed, and with this debug thing you can attach that pod or that container into already running container inside the pod. So let me show you at least the help of this, because we could not do it. I have not enabled the alpha feature in this particular cluster here because it's an alpha feature for now. So if I do debug help, so what we can see that it is giving us two options here. So this my pod is my running container already. Now what I can do is I can do kubectl alpha debug my running container pod which I have, and -i and t I can put it here, and I'm saying that image busy box. So what would happen is I would create one more container on the fly, attach to that pod directly, and then I could do all of my debugging inside that debug container. So it's going to be very useful down the line. Though it's an alpha feature now, but as it will mature, you would see that it become very useful for all of different purposes here. Let me see if there are any questions as of now. Okay, fine. So that's good. Yeah, the other thing is you would have already used logs command. So if I am inside the container, I want to look at the logs of a pod. So kubectl get pods, what I have. I can do kubectl logs, and I can specify the pod name there, and this will give me the logs of a given pod here. So we can see that I have a logs of a pod. Similarly to the exec command, if I have a pod with multiple containers, I can again do like this, like the way I did exec earlier. So I can say logs and the pod name there, or the container name in that. So I can now look at the logs of a specific container in that pod. So if I have multi-container pod, I can choose for which particular container I want. I think there's a command called all containers, which would give you the logs of all containers in one go. Yeah, there's a command like that. So you can say kubectl logs, pod name, and the all containers option. This will spit out the logs of all the containers in that pod. One useful thing is sometimes what happens is your pod is resetting frequently for some reason. You run a pod, it restarts again and again, but the pod name remains same and so on. So what you can do is you want to find out what happened previously, what happened wrong previously. So you can do this option here, kubectl logs pod name, and this previous option. This would give the logs of the previous iteration of that particular pod failure. It's very useful, and you can use it if your pod restart very frequently. Okay. So once we have done that, then to debug a cluster. So we have seen in this case is how to debug an application. Now we can look at how we can debug a cluster. So if you are running a cluster, again, that cluster, depending on where are you running, it is on-prem or it is a managed service and so on. So based on that, your debugging steps would change. But at a high level, you would kind of look at the logs of the control plane nodes. So we have already seen the logs command here. And as we know that, like in this case, I have a cluster with a kubeadm, which I've created. So if I look at the pods in the namespace of kube system, I would look at those pods which I have like API server, controller, and all those things. These are my control plane pods. So I can look at the logs of these and find out what's happening there if something goes wrong there. But again, in this case, I'm running with the kubeadm, and these are running as my pods, my control plane components. But you can run these components as systemd programs. Then you can do this general CTL command and so on to find out the logs of that component. Right? Then you can enable cluster-wide logging and monitoring. So there are different tools are available. We'll look at Prometheus quickly in this session. So that can enable for monitoring, and then similarly you can do for logging as well. You can collect the logs centrally and ship it to like an Elasticsearch stack there, and then once logs are there, you can do all the things on top of that. You can check for node shutdown. Are you running out of resources on those nodes? Is there any problem with the storage? Is there a network partition? These kind of things you would look for when you have to debug the cluster. Again, this is an overview session, so I'll not go in detail of these things. Let's go to monitoring now. So what you would monitor, what to monitor first of all, right? So you say that I want to monitor my cluster apps or whatever, but what would you monitor in general in your Kubernetes cluster? So first of all, you would monitor the health of your components, right? Be it in a control plane or the node components, like the component you're running on kubelets or kubeprocs running on each node. So how would you kind of go and find the health of those components? How would you get the metrics, like how many requests I'm getting per second for the API server? What is how many config maps I have and all those things? So how would you collect those configurations, or how do you monitor all those things, right? Then for each node, you would like to monitor the CPU, memory, network consumptions happening there, and which particular pod is taking a lot of resources, which node is more utilized. So all that information is required when you kind of look at each node level. Kubernetes object means that how many pods or how many objects you're creating in general, like how many config maps I have, how many load balancer I'm creating, and all those information, right? So for example, if you have a team of 10 people working on the same cluster, and you want to know that, okay, how many objects are created by those team members in each namespace and so on. So how would you kind of monitor those things, right? Then how would you monitor the metrics from different storage or network vendors? For example, you have a Kubernetes cluster, but you deployed then using the Rook. So Rook is the storage thing, which is deployed by the Rook software. So Ceph is the storage software, which is deployed by the Rook. So how would you kind of monitor the metrics from those? So all these things you have to kind of consider when you think of monitoring things on the Kubernetes cluster there. So how would you monitor these things? Of course, there is something called as metric server, which you can install on your Kubernetes cluster. So I have deployed that particular metric server on this particular environment, what I have. If I have enabled the metric server, I can do like this. kubectl top pods will give me the CPU and memory consumption of each pod, right? And I think there's a command called stats, but I may be wrong. No, there's no command like stat. That was a Docker command, I believe. No. And then similarly, you can do for nodes as well. So kubectl top nodes. So you can see that I can look at the consumption of resources via per node and per pod after installing the metric server. So if I need to install the metric server program on my Kubernetes cluster, which is currently running here. Yeah. So once I have, I think in the namespace of kube system. So I've installed that. Only once you install this metric server, then only you can get the metrics which I was showing you for per node and per pod level. That's one. Second thing is you can use something called as Prometheus. Prometheus is an open source monitoring solution for Kubernetes, but it can use for other purpose also, not for Kubernetes only. But we can use instance on our Kubernetes cluster. And Prometheus understands the services or the objects of Kubernetes. So it can kind of, so let me just quickly go over the Prometheus. There is a picture they have, I believe. Yeah, this is the Prometheus architecture, you can say. So Prometheus is primarily a pull-based monitoring software. Pull-based means that Kubernetes server, or not the Kubernetes server knows where to pull the metrics from. So if I kind of go back there to the setup here, yeah. So this is the Prometheus setup which I have done for this demo cluster. And if I look at the stats and then go to targets here, so you will see that I'm getting these targets. So what's happening here is when I configure the Prometheus on the Kubernetes cluster, it gets some default targets automatically because we are running in the same cluster in which we have deployed the Prometheus. So Prometheus can now talk to these endpoints, like this is the endpoint for the API server, for the nodes and the pods and so on here. So my Prometheus can go and talk to each one of these endpoints and get the metrics from. So that is a pull-based mechanism here. Those support push gateway push kind of setup also, but that's very rare. You primarily do a pull-based stuff with Prometheus. And because you are on the same cluster, it understands the hierarchy or the objects of Kubernetes, and that's why we could kind of get automatically these targets. And if I look at the metrics here, which I'll talk about in a minute, but just to kind of tell you, these are my endpoints to which Prometheus is connecting to and getting the metrics from. So that is what I would get because I'm running in the same Kubernetes cluster. Prometheus has something called as IAM series database, in which it will collect all the metrics, which you would then process with the help of something called as PromQL. So you have a PromQL language, which is Prometheus query language, which has been built unique, especially for Prometheus, and you can query the data. And once you query the data, you can then plot it on the Prometheus UI or with the Grafana and so on. You can also do an alerting with the help of Prometheus here. So I showed you these targets here, which is being configured by default with Prometheus here for my Kubernetes cluster. And these are the metrics endpoint, which I'm going to kind of get the metrics for. So for example, if I look at for API server request total, if I click on that, say execute. So here we get overall data, how many times that particular call has been made with what arguments, right? Similarly, let's look at how many config maps I have in the cluster. So if I look at HCD object counts, it will tell me how many object count I have for a given object here. Like for example, I have 11 config maps now. I'm running 0 batch jobs and so on. So all that information is there. Then you can generate a quick graph also with this. But this graph is again not very useful unless you kind of what you say, clean it up. So to clean it up, you can kind of say, okay, I want to look at, for example, resource services only. So you can not use PromQL language here. I'm just trying to put very simple example here. Sorry. So if I'm saying that, okay, give me only the resource called services here. And if I do that, what happened? Yeah. So you can see that, okay, I have 9 services. They got created at the beginning only, right? But otherwise, it will give me like how many times they've created over time. So if I deploy multiple services, you'll get a graph which is a progressive graph and so on there. So that's about Prometheus here. So if I configure Grafana is the another open source tool which I'm mentioning here. With Grafana, you can connect to your Prometheus server. So Grafana is again a general purpose graph plotting tool which you can use. So if I kind of say add data source here, then I can add data source of Prometheus, which I would do. I would pick up the Prometheus URL for now. There are multiple ways of doing that. So I'll pick up the URL for now only. And then I would just say the name. It's all fine, I believe. Just say save and test. Yeah, so this works. I'll go to the dashboard here. So currently I don't have any dashboards created. So what I would do is I would try to import a dashboard. Yeah, import a dashboard from the Grafana website. So I'll go to Grafana website here. And there are some pre-built dashboards are there. So let's see dashboards. And then search for data source here called Prometheus. Yeah. And then search here for the name called Kubernetes, right? So there would be some pre-built graphs or dashboards are there. So we'll pick up one of the dashboard from here. Let's pick up this one. And this has an ID of 1000. So I can either download a JSON file from here, I'll pick up this number which is given here. I'll go and put this thing on this request here and say load, and select my data source here and say import. So now what you will see, that you will see a cluster-wide graph, the data coming from this Grafana. So Grafana communicate to that Prometheus backend and get the metrics from there. So if I click on this, any of this data here, and click on panel JSON here, where is it? Let's see, view, explore maybe. I should show the query. Yeah, this is the query. This is the query which Grafana has made to the Prometheus to get the data from. So what will happen is Prometheus is getting the data from the Kubernetes cluster. It's saving it there. My Grafana talk to this Prometheus server and make this query there and get the data from, and then plot the graphs. This is a very simplest of what Grafana is doing. Query the Prometheus and plot the graph, right? And then there's offering commercial offerings also there, like Datadog, AppDynamics, New Relic, and Wavefront. These are solutions which are available, which are commercials, and you have to pay to use them and so on. So I think with that, we are on time with this particular topic. Let me see if there are any questions which I can take quickly. Else we'll get to the next session here. So I think it's good session. We don't see any much question here. So this Prometheus can be used for monitoring microservices for normal Docker setup, also non-kube. So Prometheus can work with Docker as well, I believe. Yeah, it works actually. So you can. So again, Prometheus is not something which is only made for Kubernetes. As I told you, right, you can put any endpoints here. So what Prometheus takes a configuration file. So if I go to status, the configuration field here, you would see that there is a config file here. In this config file, you define these job endpoints, job names. So this job name is here for a given endpoint for, let's say in this case, localhost 9000 and so on. So you can add your own endpoints here. So it's not about Docker, it can be anything. So what Prometheus requires a target. So you kind of specify the configuration here and say go to this target and get the data from. So that way you can build your own stuff, but it works with Docker for sure. Right? Can you use Splunk or Kibana? Splunk, of course, you have to pay for that. That is a logging solution, I believe, not for the monitoring thing. So there are few distinct things are available here, right? Monitoring, logging, and so monitoring you can do with Prometheus, while Splunk can be used for logging, if I'm not wrong. And Kibana is again for the logging UI and so on there. Correct. Okay, so I think we are good here. I would hand over to Prasad now. We can start with his session on BotKube. So let me see if I stop sharing here. Yep, I stop share. Stop my video also. Prasad, go ahead.
Sure.
You can share a screen and speak as well. Yeah.
Yeah. Thanks, Neependra. That was awesome talk on overview of debugging on Kubernetes. Let me share my screen now.
Yep, all good. Go ahead. We can see your screen.
Sure. Okay. Now I'll give you an idea how BotKube will help you in monitoring and debugging your Kubernetes applications. So, brief introduction about me. My name is Prasad. I work for this awesome organization called InfraCloud Technologies. As a part of my work, so my work revolves around developing controllers and operators for Kubernetes as a part of my work and as a hobby project. So, and I'm also creator and maintainer of BotKube. So I'll be covering these topics in this presentation, what problem we are trying to solve and how BotKube helps us to solve that problem. Demo around BotKube, how to install and basic uses about BotKube. I'll give an higher level idea about architecture of BotKube and future roadmap that we have. Okay, so what actually we are trying to solve with BotKube? So take a scenario, you have dev team and you have DevOps team in typical software development lifecycle. So let's suppose you have developed an application, then your DevOps team has deployed that application into a staging or production cluster. The next important thing that you need to address is monitoring. So there should be a tool which keeps monitoring your applications and notifies you on very common messaging or very common mediums that you use in your work, like Slack. As soon as any event occurs on your application, like failure, or if your application gets destroyed, then you should get a notification around it about that on like Slack and Matmos. There should be a way through which you can quickly access that deployment or access the Kubernetes applications. So the access distribution is another problem we are trying to solve. Also, there should be a common platform through which you can access multiple applications if you have multiple clusters and applications that you have deployed on that clusters. Also, if you are following certain policies and certain best practices in which the application should be deployed, and if something violates that, then you should also get feedback around it. So there are some existing solutions to address those problems. For access distribution, I don't think there is another solution than just creating kubeconfig file and distributing them across all the users which you need to provide access to. And there are open source projects like OPA, or you can write your own admission controller to enforce the policies when you create any Kubernetes resource. For monitoring, as Neependra has discussed, there are plenty of applications. So if you want to get notified about the Kubernetes resource lifecycle, then it is no brainer to use BotKube, or you can use EFK stack. You can configure Kibana actually to get a notification on Slack or Mattermost, I guess, but that is not very straightforward. You can run cron job periodically, which will just get all the events and post using webhook on communication mediums like Slack, or obviously you can uh, hire people to keep monitoring and send you messages around you. How BotKube helps? BotKube is an open source application or bot, you can say, which can be integrated with common messaging platforms like Slack, Mattermost, which notifies you if there are any events occurred on resource lifecycle, or if there are any error events on your Kubernetes applications. It also helps you to debug your Kubernetes application that we are going to discuss in future slides. You can also run specific checks based on your policies, and gives you feedback around that. I mean, if you are not following certain policy, then it will give you a recommendation with the notification. We'll see that in the demo. So along with that, it also provides you common platform. If you have multiple clusters, then with single BotKube app, you can access multiple clusters on the same messaging window. All right, so this is how typical workflow looks like for BotKube. You install a BotKube app on your workspace, let it be Slack workspace or Mattermost workspace. Then you deploy your own backend for that client on your Kubernetes cluster. So as you can see, you have to deploy your own backend for your app. So there is no other middleman in between, and so there is complete privacy, because you are controlling how your app, to what your app and how your app should respond to. And yeah, as I said earlier, your single app can also access multiple clusters. And as of now, we support Slack, Mattermost, and Elasticsearch communication channels, but we have other work in progress to support multiple channels as well. So let's enough talk. Then let me show you how to basically install BotKube app and how it can be used to debug your application. So for this demo, I'll be showing integration around Slack only. So there are multiple ways to install BotKube app into your Slack workspace. You can either go to the Slack marketplace and search for BotKube, and this will redirect you to this page. Let me just show you. So we have published BotKube app on official Slack marketplace. You can just go there, and so this is very standard practice to add any Slack app onto your workspace. I'm allowing certain permission. So this will redirect you to one page where you will get a token. You just copy this token, save it somewhere, because this is a one-time procedure. And then you can click on this link, which will redirect you to the BotKube documentation, and this will guide you how to install backend for your Slack app. So if you go into documentation, there are two ways you can install your backend, either using helm, or you can just use all-in-one manifest file and you can deploy that. You can create resources using kubectl command. So for this demo, I'll just use helm package. So first thing you need to do is add helm repo. Now I'm using, so I have two clusters, GKDO and GK staging. I'll be installing my application, my BotKube backend on GKDO first. And therefore update. This will just fetch all the latest repository from InfraCloud Helm repo. Then you can basically copy this command, and so there are certain things you need to set. For Slack, you need to set the channel in which you want to get notification. Another one is token that we have just generated. You can also configure. You also have to set the cluster name, unique cluster name, using which you can differentiate among the clusters. You can enable or disable the kubectl command execution through BotKube. So I'll talk about all the configuration in a bit. So let me just deploy this BotKube backend first. So this is the token that we have generated, and let me just replace some stuff. So let me just show you first the Slack workspace I have. So I have created two channels, dev alerts as well as STG alerts. In dev alerts, I want to get notifications about the events in GK dev cluster. So I've already installed BotKube into this workspace. I'll just add BotKube into this channel as well. Similarly here. Okay. Now I'll host a backend on my Kubernetes cluster. So if you check the setting here, right? So I have set the Slack channel to dev alerts because I want to get the notification in dev alerts channel. I'm also allowing kubectl execution. Another thing is, I'm giving GK dev as a cluster name to this backend. Okay, so let's deploy the backend. All right, so backend is deployed, and now you can see I got a notification in GK dev in dev alerts channel that the BotKube. So this implies that the BotKube backend is up and running. You can quickly do BotKube ping to check health of your backend, and you can see we got a response around that. So this is how you install your BotKube backend. Talking about the configuration stuff, So this is the default configuration, which will be provided by default when you install your backend app, BotKube backend for your app. So the configuration can be divided into two things. One is the resource configuration. So this includes for which resources and for what events you want to get notification about. So if you consider the format, we need to specify the resource name for which I want to get the notification. You also need to specify namespaces. You can obviously filter namespaces here if you want to ignore certain namespaces, and you can also configure the events for which you want to get notification about. So by default, we monitor almost all the resources, but you can as per your need, you can do the fine-grained configuration to get notification about the only resources and event types that you are interested in, right? And if you don't want to if you want to get notification about all the event types, then you can just put all here. that will also work. So again, so another thing that is included in the configuration is
sorry to bother you. Can you increase the font size, please?
Okay, sure. Better now? Is it better?
Yeah, it was better. Yeah.
Okay. Another thing that is included in the configuration is communication configuration. So here you have to basically set the credentials or the details about how you want to get configured. You want to communicate to your Slack or Mattermost app. So for Slack, you just need to set token and channel name. For other backends, there are other stuff involved. So these are the default values. If you already know Helm, so these are the default things that are set in values.yaml. If you want to override this, that can be done using -set command. So that's how we are actually setting this configuration. But if you want to deploy this backend using all-in-one bundle, then you can just refer to this file, deploy all-in-one, and you can just manually remove the redundant resource configuration, and you have to set the communication details here. Once you edit this file, you can just use kubectl create -f and this file name to deploy all the BotKube components. Okay, so we are done. Any questions around deployment, backend deployments?
I can help with the question there. One question was there: can we configure multiple cluster while configuring QPod?
So I'm going to cover multiple cluster things in next slide.
Okay.
So
fine.
Yeah, that will resolve that question.
Okay. The other question leads so right.
Sorry, I didn't get the question. Can you repeat?
Yeah, just go up a bit. Yeah, Nicholas. Yeah. No, you come down. So the question is: will BotKube backend be an independent pod deployment in a cluster?
Yeah, exactly.
Yes.
So when you talk about controllers in Kubernetes, the controllers are nothing but the deployment. You can deploy any app basically as a part of deployment in your Kubernetes cluster. The controller is itself an app, and you have to create a deployment to deploy that app into your Kubernetes cluster. Okay, so let's see now BotKube in action. Now I have configured the BotKube to send events in Dev alerts channel, whatever events are there in GK Dev cluster. So let me create a deployment. So this is a deployment manifest. This will just create one pod of WordPress container, and there are some readiness probes that I have set, and these are expected to fail. Okay, so let me just create this deployment. Let me just replace it. You can see I have got an event about resource creation. Let's wait for a moment. Yeah. So as you can see, I also got a notification about failure. So if you want to escalate that issue to a particular team, then you can just add new members in this channel, and they can just query to BotKube app to debug this application. Before we do that, I'll just show you the help, BotKube help. So yeah, these are the set of commands BotKube supports. These again can be divided into two parts. So of this command is specific to BotKube, and you can also use BotKube to execute kubectl commands as well. The format is same as the execution of the format for executing kubectl command is same as the standard kubectl commands here. You just have to replace kubectl with BotKube. I mean, for example, to get pods, the kubectl command is kubectl get pods. But if you want to execute that through BotKube, then you have to just replace kubectl with BotKube, and rest of the command will remain same. So if I do kube get pods, I'll get list of pods, and likewise I can execute any kubectl command. Another set of commands is actually BotKube specific commands. If you want to disable the notification, you can just execute kubectl notifier. So status gives you current status. If you want to disable notification, you can say stop. So this won't send you notification about an event. To restart it, I can just give notifier start. The thing that we have already discussed, that is for health check. Filter is for, I'll talk about filters in a moment. So let's see about event we got, what notification we got. So we got notification about deployment creation as well as pod creation. But if you look at the notification text, it has also given me recommendation about the latest tag that I have used. So I have set a policy that if anyone uses latest tag in their deployment manifest, then this recommendation should be added. Okay. So now you can see I also got an error event about the pod failure. I can just use BotKube command to get this status. And as Neependra has already discussed, the first thing that we usually do to debug any application, we describe that resource. So let me just describe the pod. Yeah, you can see the readiness probe is failing. You can also execute other commands in order to debug your application. For example, if you want to get logs for that pod, you can just use BotKube logs and pod name. It will just give you the logs. If the log size is too large, then the logs will be uploaded as file. You can just download that, and you can then try to debug that application. So yeah, so this is for executing kubectl command. Another one is to disable enable notifier, health checks, and filters. So yeah, as you can see, I have gotten a recommendation about the image tag that I have used. So that is done via filters. I'll talk about filters in detail in the next slides, but to give you an idea about what are filters. So filters are run on every Kubernetes event, and based on the logic that we have in individual filters, it will modify the event and add recommendations and modify the event structure before BotKube actually sends that event to your client, like this Slack client. Okay, so each filter is responsible to do certain task or certain operation and modify the actual event. All right, so now we know what is the cause of that failure. Let's try to fix that. So what I'll do is I'll just edit the deployment. Okay, so first thing I'll do is I'll remove the readiness flow for now. Also, I'll change the image tag to something concrete. Okay, so if I save and close this, my deployment will be updated. And with update event, I'll also get the diff between the older deployment and newer deployment. As you can see, the image tag has changed, as well as the readiness probe is removed. Okay, so this is how you'll get notification about the resource life cycle in Kubernetes, any Kubernetes resource, as well as you can also configure BotKube to get events about failure, and using BotKube commands, this is how you can debug your application. Any questions around that? So BotKube doesn't require an author. Yeah. So by default, we provide read-only access to all the Kubernetes resources. If you check the BotKube help command, so these are the set of kubectl subcommands that BotKube allows. Also, if you look at the cluster role that we set, so for all resources, we just get access to these three what you call methods. But you can always modify this according to your requirement. If you want to provide access to only certain set of resources and only certain methods, then you can edit this cluster role and to provide more restrictive access to BotKube users. But yeah, once the backend is deployed, it has no other authentication or authorization mechanism. Okay, so moving forward. Now you have seen BotKube in action. Let's discuss in brief about the architecture. So this is very high-level architecture about how BotKube actually works behind the scenes, how BotKube backend works. So we have informer controller in BotKube backend, which actually reads the configuration that we have provided. So based on your configuration, it registers watchers on the Kubernetes API server. So once any event occurs on the configured resource, the informer controller gets notified by API server. So let's call it as KTS event. So this is standard Kubernetes event that Neependra has already talked about. Once we get Kubernetes event from Kube API server, we have something called event manager, which actually extracts only the required information that from the Kubernetes event and ignores the redundant stuff. Okay, let's call it BotKube event. So once we stream the Kubernetes event into BotKube event, we have something called filter engine, Now filter engine is quite interesting because once we get the BotKube event, we have registered filters which will do some checks on the Kubernetes event and the Kubernetes resource that we got event about. It passes the Kubernetes specs, and as per your logic, as per your policies, you add recommendations, warnings, and other stuff in original BotKube event. So each filter will transform the BotKube event, will add or remove some stuff from the event. Once we run all the filters, then event notifier sends that event to communication mediums like Slack, MetaMost, or Elasticsearch. So this is for notifier side. Now we have also seen the request response kind of stuff that BotKube does. You send some commands to BotKube, and BotKube backend will send you a response back. So we have something called bot interface for that, to which the individual communication client communicates with. Once you send any message through that client to BotKube backend, we have something called executor, which passes that message, and it decides whether this is kubectl command or BotKube command. Based on that, it will either execute kubectl command, or it will do the configuration stuff on BotKube, and it will send the response back. So this is how BotKube backend works. Now talking more about filters, these are list of default filters which does basic checks on certain Kubernetes resources. You can always add, so BotKube also supports the custom filters. You can add your own filter based on your policies. For example, image tag checker, which will just check the image tag which is used for the containers in deployment or stateful set specs. If the image container contains latest image tag, then it will add warning recommendation in the BotKube event. So let's look how you can write your own filter. So we have documented here. Okay, we have something called filter engine, which actually get list of all the filters and run them sequentially. So this will actually need some knowledge about Golang. So if some of the folks doesn't know Golang, then I'm sorry, you can just ignore this part. Okay, so this is the filter interface. In order to implement this interface, your your struct should implement run and describe method. So this is how the skeleton for your any filter looks like. You will have a structure, and on the structure you have to implement these two methods. Okay, on the run method, what you get is, if you look at the parameters, you get object, which is Kubernetes, which is runtime object. If you talk about the Kubernetes side, but if you don't know client Go library well, client Go SDK as well, then you can consider this as the object which points to the Kubernetes object specs, of which we got notification about. Okay, so this object contains the Kubernetes specs in short, and then you have BotKube event. So you parse this object. So in order to do some operations on as a part of this filter, you have to actually parse this object and do some checks, and accordingly you add warning or recommendations to this event. So as I'm implementing this image tag checker, for example, what I need to do is I need to pass this object into deployment or stateful set or pod specs, and then I'll pass that spec and check the container image tag. Okay, if the container image tag contains latest image tag, then I'll modify the event and add recommendations in the default BotKube event. Okay, so this is how I'll implement that logic. I'll check what is the event kind. If that is pod, then I'll transform this object into pod spec. Into pods, I'll actually do a type assertion on this, and I'll try to convert this object into pod type object, pod type struct or object, whatever you call this. And then I'll pass this struct, pass this specs, and check what is the image tag. If that image tag contains letters, then I'll add the recommendation. So this is the logic for passing the object specs and adding the recommendations in the event. Looks like once you have implemented the logic for your filter, this is how you have to register that filter into filter engine, so that filter engine will run your filter on every Kubernetes event occurrence. So in init, you can just add this line called register method and just pass your filter struct to that method. Okay. Once you have done that, you can just use make container image. This will again rebuild your backend code. It will create an container image. You push that image and you just upgrade your BotKube backend with that image. All right. So likewise, you can, based on your policies, you can add some checks around the Kubernetes specs, and you create a dedicated filter for that. You register that filter, and that will be run on every Kubernetes event occurrence. All right. So you have talked about filters. I think likewise you can implement your own custom filters. So let's talk now about how BotKube works with the multiple clusters. Okay. Now I have two clusters. So in GKDev, I have already installed BotKube backend. In staging cluster as well, I need to install the backend. So the configuration or the help command for installing the backend on staging GK stage cluster will look like this. So you need to use the same token that you have used to install the dev backend, so that you can use the same app to communicate to both the clusters. And to differentiate among the clusters, you can change the cluster name. So in the backend, which I have deployed in GKDev, I have put name GKDev for that. Likewise, I can use GK STG name to differentiate between the dev as well as staging BotKube backend. Another thing is I'm also setting another channel, that is STG alerts channel, that I have already created in my Slack workspace. So this backend will send me notification about the events in GK staging clusters into this channel, staging channel, right? So let me just deploy the backend on staging cluster just to verify once. Yeah, you can see I got notification. Now let's check health of all the clusters. Now, if you do BotKube ping, I'm getting two responses. One is from GK stage cluster and one is from GK dev cluster. Okay. So by default, so let me also create a resource here. So yeah, as you can see, if the resource lifecycle events as well as the failure events on GK staging clusters, I'm getting notifications about it in stage alerts channel. So by default, if you execute any kubectl command here, this will run against the staging cluster. You can also see the cluster name. And if I execute same command in dev channel, the command will be executed against. Okay. What if if you want to send direct message to BotKube? So if you don't want to spam other users that are there in this channel, you can also send DM to BotKube to execute certain commands. Okay. So if I just do BotKube get pods here, I won't get any response because BotKube doesn't know on which cluster we want to execute that command. So for that, what you have to do is you have to set cluster name as well. So if I specify cluster name as gkdev, then this command will be executed against dev cluster. If I use, if I want to execute this against staging cluster, I'll just give gkstg then here, right? So this is how you can use single platform to use multiple clusters as well. Any questions around this? But BotKube internally doesn't have logic, so I'm responding to this question. How scaling is designed for BotKube? So BotKube internally doesn't have any logic to scale up or down. You can always configure pod autoscaler for that. But I mean, even if there are multiple events happening or multiple events BotKube is getting from API server, still it won't take much computation power. But as I said earlier, BotKube internally doesn't have logic to scale up or down. You can configure pod autoscaler for that. Suppose any service in cluster crash, then the BotKube can restart if the logic is recommendation. Interesting question. So the configuration that we provide while installing BotKube, that is saved as a part of config map. Okay, let me just show you.
So I believe it's not about the BotKube. It is the Kubernetes who has to restart the app, not the BotKube.
So with any service in the cluster crash, did BotKube can restart? Okay. As I said, BotKube has only read-only access. It can't, delete or create stuff for security reasons. You also can't execute commands like BotKube create or BotKube delete pods. By default, as you can see in help, there are only set of subcommands kubectl subcommands that you can use. BotKube by default doesn't provide BotKube doesn't provide write access for your Kubernetes resources. So yeah, this will just notify you, but if you want to restart it, you have to do it manually. Apart from you can then prepare commands. Prometheus Alert Manager. Okay, so BotKube can be integrated with multiple communication mediums like Slack, Mattermost, Elasticsearch. I'm not sure if Alert Manager also sends notifications to other communication mediums. That is one thing. Another thing is in single platform, you can access multiple clusters. Also, you can execute commands right from your messaging windows on your Kubernetes cluster. You don't have to create kubeconfig, distribute that kubeconfig among users. If they want to get, if they for example, some users might just want to see the status or just see the logs of particular application. For that operation also, you have to create kubeconfig to provide read-only access to the users and distribute that kubeconfig among the users that wants access to that Kubernetes cluster. So instead of that, you can just create a channel, or you can add the people who needs that access to this channel, and they can just access the Kubernetes cluster using BotKube commands. So that will save a lot of time and efforts also. This is written in Go. So if you look at the GitHub repo, this is the GitHub repo for BotKube. This is mainly written in Go, like most of the Kubernetes controllers. And if you want to contribute, we have created documentation around that. You can follow this, and yeah, feel free to raise any issues, submit PRs. If you have any feature request, you can just ask or create an issue here. We can discuss around that. Also, free to join the Slack channel we have for BotKube. This is, I think we have link here, but that is join.botkube.io. Feel free to join the Slack, and we can discuss about if there are any feature requests. If you want to get started about, if you want to get started on contributing to BotKube, yeah, feel free to ask questions in the Slack channel. All right, there are any questions? Yeah, I don't think so. All right, so this is how you can use BotKube to monitor and debug your Kubernetes applications. We also have an interesting thing going on in our development branch. We have almost finished the implementation for team support, and in upcoming release, you'll be able to configure the update events to monitor certain field also. I mean, if you take example of deployment status, then you can see. So there are some stuff that, for example, unavailable replicas or some flags, or take example of if you have created a job and if you want to check state, if you want to keep monitoring on the status of that job, if that is going to be succeeded or getting failed, then you can configure BotKube to monitor that specific field in the status, and you will get notifications around that if there are any updates into that. So that is another interesting feature we have added. We are also implementing support for custom resources. So RBAC stuff is quite interesting, but we are not implementing that right now. But we are allowing users to restrict command execution to channel only. So as of now, you can actually run BotKube commands from any channel. For example, here also, if I provide cluster name, so I'm executing this in dev channel, but the notifications I'm getting in dev and staging alerts. But you can execute BotKube commands outside those channel as well, provided that you specify the cluster name. I'll have to just invite BotKube here. But you can restrict that in the upcoming release. So yeah, this is what is happening on development right now. As I have talked about this earlier, this is the GitHub repo. The documentation is on botkube.io. Feel free to join.botkube.io to join the BotKube Slack workspace. And yeah, feel free to contribute if you have any issues, any feature requests, any PR. Feel free to send it on this GitHub repo, or we can talk on Slack as well. All right, yeah, that's all I have. Any questions?
So there's one question on the chat now, and I have one question.
Okay, is BotKube secure when interacting with other messaging services? Yeah. So if you look at the deployment and the architecture as well, so for each BotKube app, you have to host your backend, and the backend will be deployed by you only. And based on the official using official SDKs for particular channel, for take example of Slack, you install Slack app into your workspace, BotKube Slack app into your workspace, but the backend for that app you have to do it on your own. I mean, you are the only one who is responsible for handling the logic of that particular Slack application. You install backend for your app into your own cluster, and using official SDKs, it will communicate with BotKube client. So there is no middleman between this communication. All the communication happens through official Slack API server, I would say, or I'm not sure what is the standard term for that, but the standard API server who is responsible for sending or receiving messages in this particular Slack client is the same which is responsible for the communication between your BotKube backend and your BotKube app. So yeah, for the most of the integration, we use official SDKs only, and yeah, you have to deploy your own backend. So I don't think it will the privacy would be any concern here.
Okay, thanks, Prasad. One question I have regarding the maybe filters might be the answer for that, but I want to just confirm. For example, if we define some resource request and limit for my pods, and then when I see that okay, this pod is going to consume let's say 80% of the limit what I have given, I want to get an alert for that. So is that something which we can do now, or we can write our own filters for that?
Yeah. So, I mean, you obviously are familiar with client go SDKs. So, for each Kubernetes, with each Kubernetes event, you also get runtime object, right? And you can pass that runtime object and check what are the values in the status. And as you said, if the status contains the resource consumption more than certain limit, then you can obviously modify the event struct, add warning or messages in this event before you send that actual event to your communication medium. So this is one approach. But after the next release, you can also monitor certain fields into status using JSON path. That is not released yet, but once we release the latest, actually version 1.0, then let me show you the configuration if I have it here. You can set JSON path into update configuration, which will monitor the certain field in the status like this. And if there are any updates in this field, then BotKube will send you notifications around that.
That's really good feature like that.
Yeah. Thanks. Okay, that's all I have. Thanks guys for listening. I hope you will find BotKube helpful. Yeah.
Yes.
Handling.
Yes, I'm definitely going to put in my production server. I have not been using so far, but I think with this demo, I got to insight, and I'm definitely put it there. Yes, so video will be there. Can you ensure this? I want to share my screen for quick update there.
Sure. Let me stop.
Sure. Yeah, so guys, as you know that this is what we are doing as a community, right? It's not driven by, though I'm moderating it, but it's not that I want to kind of keep presenting all the time, right? So we would be doing more of these meetups, these events, and these are some of the options or some of the thoughts that I have about topics which you want to cover in future meetups. So if you guys want to kind of take any one of these or have your own idea which you want to kind of talk about, but preferably intermediate and advanced, that's what my target is, because a lot of basic content is already there on the net. So we can kind of pick up, for example, let's say OTAs, what is API gateway, how do you use it, right, and so on. these kind of things are not available very easily on the net. So if we can pick up some of those intermediate to advanced topics, that's what the primary target is going to be for this meetup, what I was thinking. But yeah, we'll see how the road is going to be. So thank you all guys. One quick note, if you can drop me the location from where which you have joined this event. I'm trying to kind of get the people who are not from Bangalore who has joined this meetup group and attended this meetup. That would be helpful. And any feedback, please leave a message or drop a note as well. Yeah. Yeah, recording will be available, so don't worry about that part. It's not about teaching. It's not a teaching thing, right? It's about sharing the knowledge. Teaching happens separately. So yeah, we'll try to be a bit slow, but it's not a teaching platform or trying to teach somebody from the scratch, right? So assume that you know something and you want to kind of enhance your thing there. So yeah, it's not a session, and then guys, the speed varies depending on the speaker to speaker. We'll try to manage that, but yeah, it all driven by the person, right? Who is going to deliver the session. Yeah, recording would be there, so don't worry about that. All we are recording, and we'll share the recording in a while, in a day or two. Okay, thank you guys. Hope you liked it. Thank you.